during the last class,
I'm creating a video for this
that is the
lesson,
Noity guy
and if
was
you
teaching
think
you about
that you're having trouble
the
with this
different
topic,
experiments
then
that
you
were
can refer to
conducted
this video
in order just
in the
to
future.
find a model to describe an atom. Okay, they were talking about an experiment that was made with the light, and they were talking about the photoelectric effect. That, by the way, that photoelectric effect is the principle behind the solar panels. Now, I don't know in that lesson that guy was talking about Rutherford, because I remember that Rutherford was trying to prove that Thomson model was correct, and he was bombarding a thin plate of gold with alpha particles. The alpha particles, they are positively charged particles, and he realized that some of the beams, see, he was bombarding that with alpha particle in more, the beams that he was using to bombard the gold were deflected to a very high angle, and he wasn't expecting that. So he arrived to the conclusion that somewhere inside the nucleus there were like a lot of positive charged particles, and he called them the protons. Okay, they were explaining all of that in that lesson, how the atoms they were discovered and the different models that they were using, the scientists were using over time, and how that model of the atom was evolving until they arrived to the modern atomic theory. It's a theory. See, in the next 50 years, can you expect a change in that theory? Of course, because remember that theory, they change over time. Usually, when you have more progress in the technology field, then you have more instruments just to prove or disprove hypotheses. They were talking about all of that. They were talking about the Einstein experiment in which, see, he is able to create an equation, or come out with an equation to explain the behavior of the electrons in the atoms. E is equal to the Planck, which is an H, constant multiplied by the frequency. And after that light experiment, they arrived to the conclusion that at certain frequency, it depending on the element that you're using, at certain frequency, the electrons, they are gonna be able to jump from one level to the next one, and they were discussing the quantum number. They were talking about all of that, how the theory was developed over time. After all of that discovered, there is something that is clear. You have a region there in the center of the atom that is packed with the products. This center over here, Rutherford called that center the nucleus. I don't know who was the scientist that discovered the neutron, but the scientist that discovered the neutron, the scientists that discovered the neutron, right to the conclusion that the neutrons were located inside the nucleus. Okay? Now, according, one more time, with the modern atomic theory, there is a region around the nucleus in which you're going to find the electrons. If we call this region the electron cloud. Questions about that? No. Now, another experiment by other scientists, they arrived to the conclusion that most of the mass of an atom is given by the amount, oh my goodness, amount of protons and the amount of neutrons that are located in the nucleus. Electrons, they are so small that they don't play any role in the mass of the atom. However, they're super important for when the elements they are reacting with each other. See, for the chemical properties, electrons they're responsible for that. Okay. Questions until here? No? Okay. So atomic number. The atomic number, the ones that you find in the periodic table, is equal to the number of protons. So if you go to the periodic table, you have sodium, and on top of that you see an 11, that's the atomic number. That's the atomic number. What does that mean? That inside the nucleus you're gonna find 11 protons. Now, atoms, they are neutral. What does that mean? That they don't have a charge at all. See, neutral. If you have 11 positive particles in the nucleus, you need 11 negative particles, electrons. Okay? Electrons are the negative particles. You have 11 positive plus 11 negative. You have a neutral atom. So when you look for the atomic number is giving you the number of protons and the number of electrons. Ms. Ramos, the atomic number is giving me the number of neutrons. The answer is no. Who's giving you that number? Okay. And that's the next concept that lesson was discussing there. Mass number is the number of proton plus the number of neutron. Ok, mira como Alisa me está enseñando el teléfono de ella. Mira como tiene, mira, rainbow everywhere. Let's say that the same sodium atom that I was talking about has a mass number equal to 23. Number of proton is the same always. The number of proton is equal to the atomic number, and the atomic number is the social security number of an element. You change the number there, you change the element. 11 protons. How many neutrons do I have? How many neutrons? If I have an atom of sodium with a mass number equal to 23, how many neutrons do I have in there? Okay, you don't know math. 11 plus 12 is equal to 23. So sodium 23 has 12 neutrons. Questions about that? No. Okay. I love that part. And this is the mass number, remember, because according to the scientists that were doing all the discovery, most of the mass of the atom comes from the mass of the nucleus. And what are the subatomic particles that are located on the nucleus? Protons and neutrons. Electrons, they're too small. Super important, but they are too small. Questions about that? No? Okay. I'm gonna continue with isotopes. Miss Ramos, what are isotopes? What are isotopes, Miss Ramos? Atoms of the same element with different number of neutrons. Atom of the same element. So let's say that I have over here 3 atoms of, I don't know, carbon. Carbon has an atomic number equal to 6. So over here, atomic number, let me put it over here. Atomic number is equal to 6. That 6 is the number of proton. So I have plus 6 proton plus 6 proton in my 3 atoms, because the atomic number is the social security number of an element. Okay, and since the atoms, they are neutral, I have 6 electron, 6 electron, and 6 electron. Okay, but let's say that over here, instead of having 6 neutrons, I have 5. On the second one, instead of having 6, I have 7. In the last one, I'm gonna have my 6 neutrons. Mirama, what is that? What are you trying to say? See, I'm trying to explain isotopes. Atoms of the same element with different number of neutrons. How, Miramos, we're gonna identify the isotopes? There is a thing that is called isotope notation. So let's say that you want to represent the first one, the one that you have over here. If you have 6 protons and 5 neutrons, the mass number of the first one is 6 neutron plus 6, 5 neutron plus 6 proton, 11. How are you gonna write, see, that information in isotope notation for the first one? Carbon, that's the symbol of carbon. Over here, I'm gonna put the atomic number. Over here, I'm gonna put the mass number. Second one, you have 6 proton, 7 neutron. If you add that mass number is equal to what? 13. So you have carbon 6 because they are atoms of the same element, mass number equal. See that? And for the last one, let me use another color. Okay. I have carbon 6 because they are atoms of the same element. Have you heard about carbon 14? Yes. 14 is the mass number. How many neutrons do I have in carbon 14? How many neutrons? I have 8 neutrons. If this is what makes carbon 14 radioactive. Understand isotopes? Okay. You're not gonna answer me, but I'm gonna continue. Isotopes are atoms of the same element with different number of neutrons. Okay? So, let's say that I have, I don't know, sodium or potassium, beryllium is 4. Beryllium atomic number is equal to 4. If the atomic number is the number of protons. Okay, if this is the isotope notation for beryllium, how many neutrons do I have here? How many neutrons? You remember that number over here is the mass number. I have in this isotope 6 neutrons. Understand that? Okay, you're not paying attention, but I'm gonna continue. Okay, knowing that, I'm gonna move to the next topic. Okay, so I'm gonna continue. Yeah, I'm gonna continue with isotopes. Okay, by the way, I'm gonna stop the recording and then I'm gonna calculate to put the numbers in there. Let me see, what do I have in here? I have 0.0137 multiplied by 204, and the answer is so after multiplying the percent of abundance reading as a decimal by the mass number of each isotope. See, you multiply all the percent of abundance reading as a decimal by the mass number of each isotope, and you add all the numbers. And that's the average atomic mass of lead. Now, Ms. Ramos, you're talking about mass and mass of an element. What is the unit of measurement that we use for mass of an element? AMU, atomic mass unit. Okay, so you have a video showing you how to do all of this. The lesson in Ingenuity that is showing you how to do all of this. You shouldn't have any problem calculating the average atomic mass. Okay, by the way, this is problem number 3 from your homework. So if you don't want to think or just to figure it out how you have to find the average atomic mass, you open the video and then you watch the video and you copy that down for problem number 3.